So it says here, in the linear system below, AE minus DB equals 0. Show that system does not have exactly one solution. So for something to have exactly one solution, the slopes of these two lines must be different. Or in other words, A to B ratio is different than the D to E ratio. Okay, so if that's for it to have one solution. So if they are the same, the ratio is the same, they cannot have one solution. That's what we're going to show. So A to E is equal to D to B. I'm just rearranging this equation. And then I'm going to write the ratio of A to B like this. I'm just going to just cross multiply this. And I end up with A divided by B. So the B goes in the denominator here. And the E goes in the denominator on this other side. And what that's showing me is that the A to B ratio, or A over B, is equal to the D to E ratio, or D over E. Okay, so this means that therefore, these are parallel. Okay, so if they're parallel, they cannot have one solution. Okay, does not have one solution. It could have infinite solutions or no solutions. If they're parallel and the same, they would be infinite. If they're parallel and they're different, they could be no solution. Now, because we don't know, we know that there is a multiplier here to here that goes from A to D and B to E, but we don't know if that same multiplier applies to C to F because we don't have any information about C and F. So although we know they're parallel, we don't know if they are the same line or if they are different lines because we don't know the ratio of C to F. So I'm just going to write here C to F ratio is not known. Therefore, could be 1, parallel. They have to be parallel. Parallel and same. That will give us infinite solutions. Or there could be another situation where they are parallel, because we know that they're parallel because the statement that we just proved, and different. That would give us 0 solutions. Okay? Now, we could also do this in a really long-winded way, and we could actually just solve these two equations. So I can just take a look at these two relationships and make them into y equals mx plus b. And that's what I've done over here. So I've made the ax plus by equals c. I rearranged that equation. So I solve for y. So I've moved the negative ax to the other side, divided by b. And I can see that a divided by b is negative a divided by b is my slope. And I could do the same thing here. I can take the equation, subtract dx from both sides, divide both sides by e. And I can say that negative d over e would be the slope of this line. Well, we have proven up here that a over b ratio, although our slope is actually negative, the a over b ratio, I'm just going to highlight that, the a over b ratio here and the a over b ratio here are the same. The d over e ratio is equivalent to that, and we have the d over e ratio here. So these two lines are in fact parallel. So we know that they can't have one solution. What we don't know, though, is we don't know if C over B and F over E are the same or different. If they give us the same y-intercept or different y-intercept. So again, we can't conclude that it's infinite or 0. We just know that they are parallel and either infinite solutions or 0 solutions.